Hi there, my name is Julia Matto, and today I'll be performing the can crushing experiment to show a real-life example of the fascinating effects of Boyle's law. The materials which I will be using today are a bowl, it doesn't matter the size as long as it's large enough for 2 to 3 pop cans, ice water. We need to make sure the water is very cold to provide an adequate environment for the water to seal the opening of the can, condensing and reducing the pressure inside to cause the can to be crushed. Tongs. Due to the high heat of the cans, we want to avoid using our hands to touch the cans. I'll be using salad tongs. And some empty pop cans, of course. I'll be performing this experiment with both a pop can and 2 beer cans, but I suspect that the difference between the two will be minimal. A heat source. If you're performing this experiment in a proper lab, feel free to use a Bunsen burner. Since I'm in my kitchen, I'll just be using my stove. And finally, a sauce pot. This will be used to boil the water and to hold the cans. Try using a saucepan which is tall enough to cover the pot. Once you've gathered the materials required, it is time to perform the experiment. The first step is to heat the water. As we wait for it to come to a boil, we will prepare the cans. We will fill them with about 30 milliliters of water. You can measure this by using 2 tablespoons. Once the cans are filled and the water is at a boil, carefully place your cans inside the pot of water. We will wait for about 2 to 3 minutes for the can to reach a sufficient temperature. As we wait, fill the bowl with ice and cold water. Make sure not to do this too early as we don't want the ice to melt. Now, with an abundance of caution, we will use the tongs to remove the cans from the pot. As you move to the bowl, flip them over and submerge them in cold water. Observe as the can begins to crush. As said before, this crush is made possible by Boyle's law. Boyle's law is defined as a fixed temperature. The volume of the gas is inversely proportional to the pressure exerted by the gas. This means that P1 times V1 equals P2 times V2, where P1 is first pressure, V1 is first volume, P2 is second pressure, and V2 is second volume. The University of Washington describes Boyle's law's relation to this can crush as when the can is filled with water vapor, the pressure inside the can is greater than the pressure on the outside of the can. When immersed in the water seals the opening and the vapor inside the can crushes. This reduces the pressure inside the can and causes it to become crushed. Let's elaborate on this concept. With our initial can filled with 30 milliliters of water, the liquid molecules are relatively close, flow, and take the shape of their container. Once we introduce heat to the can, the molecules begin to become excited. They vibrate and bounce off the walls of the container, eventually becoming water vapor, as mentioned before. Once we submerge the can into cold water, the vapor quickly returns to water. This explains the crush. Now to quickly recap this experiment. Today we've performed an interesting can crush due to the wonders of Boyle's law. To perform the experiment, you will need a bowl, ice water, tongs, a pop or beer can, a heat source, and a sauce pot. How does this occur? Well, as mentioned multiple times previously, we have Boyle's law to thank. This law states that P1 times V1 equals P2 times V2, or first pressure times first volume equals second pressure times second volume. This relates to the experiment because when heated, the water, a liquid, turns to water vapor, a gas. Once placed in cold water, the gas quickly returns to a liquid. This causes the can to crush. A gas. Next time you find yourself with a pop can and a pot of boiling water, watch the effects of Boyle's law before your own eyes. Thank you for listening. Have a great day.